Hello my dear friends, how are you all? I hope you all are fine. So my dear friends, today we are going to discuss lecture number 5 of polynomials. Okay, so my dear friends, I hope you will enjoy this lecture. Okay, so now my dear friends, this lecture is going to be very amazing because in this lecture we are going to be discuss a lot of problems, okay, with unique solutions. Okay my dear friends, so I hope you will enjoy this lecture. So without wasting the time, let's start my dear friends. Yes, so now my dear friends, we are going to discuss about factorization of polynomials. What is? Yes, factorization of polynomials. So my dear friends, this topic is very amazing my dear friends, so you have to be listen very carefully. I hope you will enjoy this lecture my dear friends. Yes, so now my dear friends, factorization of polynomials. Okay, factorization of polynomial is the process of expressing the polynomials, is the process of my dear friends expressing the polynomials as the product of two or more polynomials, as the product of two or more polynomials. Okay, so my dear friends, factorization means what? Factorization here is factorization of polynomial polynomials is the process of expressing the polynomials as the product of two or more polynomials. Okay my dear friends, I hope you get this one. So factorization of polynomials is the process of expressing the polynomials as the product of two or more polynomials. For example, let's suppose we have a polynomial like x square minus x minus 6. So if we factorize this polynomial, so my dear friends, we get x minus 3 into x plus 2. So this is the factors of this polynomial. These are the factors of this polynomial. Okay, we can convert it into with the help of factorization method. We will see later in this lecture. Okay, yes. So now my dear friends, now what is factor theorem? Here we are going to discuss the factor theorem. Okay, now the factor theorem states that if p of x is a polynomial of degree and which is greater than 1, and a is any real number, then we can say that x minus a is a factor of p of x if p of a is equals to 0. Means if the value of a, if this a satisfy the polynomial p of x which is equals to 0, means if we put the value of a in the polynomial of x in place of x, okay, and if the result is 0, then we can say that x minus a is a factor of this polynomial, okay. Now second statement is that p of a is equals to 0 if x minus a is a factor of p of x. If x minus a is a factor of p of x, then we can say that p of a is equals to 0. So this is the factor theorem. So both these statements are related to each other. Okay, both these statements are converse of each other. Okay, now let's see the proof of factor theorem. What is? Yes, proof of factor theorem. So my dear friends, here is. So now my dear friends, here we will prove the factor theorem, okay, according to which we can factorize the polynomial. So now my dear friend, let's suppose consider a polynomial. Listen to me very carefully, my dear friends. P of x, okay, we are considering this polynomial. So now which is divided by x minus a, which is divided by what? X minus a. Now then here is we have P of a is equals to 0. What is P of a is equals to 0? So now my dear friends, using remainder theorem, P of x is equals to, we can write like this. Here is x minus a into q of x plus P of a. Okay. Now my dear friends, from this statement we can write here is like P of x is equals to x minus a into q of x plus 0. Plus what? Yes, plus 0. So now my dear friends, we get P of x is equals to x minus a, okay, into q of x. Okay. So now my dear friends, with the help of this statement, with the help of this expression, we can say that therefore x minus a is a factor of x, factor of P of x. Okay. So from this we can say that x minus a is a factor of P of x. Okay. So my dear friends, I hope you understand these things. Okay. So now my dear friends, here we are going to prove the second statement like this. Now here we are proving this statement. Now we are going to prove this statement. So now my dear friends, in this, okay, if P of x is equals to x minus a, we can write it with the help of remainder theorem, q of x plus P of a. So now my dear friends, if x minus a is a factor of P of x, then the remainder must be 0. Then the remainder what? Must be 0. Okay. So my dear friends, here is x minus a exactly divide P of x. Okay. So x minus a exactly divides P of x. Okay. So now my dear friends, therefore we can say that P of a is equals to 0. We can say that P of a is equals to 0. Okay. I hope my dear friends you understand these things. So now my dear friends, there are following statements. There are following statements which are equivalent for any of the polynomials. So the following statements are equivalent for any polynomial, P of x. Okay. So now what are these statements? So the first statement is that the remainder is 0. The remainder is 0 when P of x, means when the polynomial of x is exactly divided by, yes, x minus a. Okay. So it is saying that P of a is equals to 0 when P of x is exactly divided by x minus a. Okay. Now Second statement is x minus a is a factor of p of x. We can say that x minus a is a factor of p of x. Okay. Third statement is, or we can say that a is the solution to p of x, or we can say that a is the solution to p of x. Now, and fourth statement is a is a zero of the function p of x. Okay, or p of a which is equals to 0. Okay, my dear friends, I hope you understand these things. So these are some statements, okay, which are equivalent for any polynomial p of x. Okay, my dear friends, I hope you understand these things. So now, my dear friends, here is now how to use factor theorem. So my dear friends, there are some steps, okay, to find the factors of the polynomial using factor theorem. So step number 1 is, okay, if let's suppose we have a polynomial, f of x. Okay, we have a polynomial f of x. If, my dear friends, if f of minus c is equals to 0, then what? Then x plus c is a factor of the polynomial f of x. Okay, my dear friends, I hope you understand these things. So now, my dear friend, this is saying that if let's suppose we have f of x, we have a polynomial function which is f of x. Okay, now if f of minus c, there is a value minus c, if it satisfies, if we put the value of minus c on this function, if we get 0, then we can say that here is x plus c, means x plus c is what? Is a factor of the polynomial f of x. Okay, now if you talk about step number 2, so my dear friends, if f of d upon c, if we put the value d upon c, if we get 0, then, my dear friends, then cx minus d is a factor of f of x. Okay, is a factor of polynomial f of x. Okay, my dear friends, so in this case we have cx minus d is a factor. What is cx minus d? Okay, I hope, my dear friend, you understand these things. Yes. Now the step number 3 is, if, my dear friends, f of minus d upon c is equals to 0, then in this case cx plus d is a factor of f of x. I hope, my dear friend, you understand these things. Now step number 4 is, if f of c is equals to 0 and f of d is equals to 0, and f of d is equals to 0, then in this case, my dear friends, x minus c and x minus d are factors of the polynomial factors of the polynomial f of x. Okay, now my dear friends, if we have f of c is equals to 0 and f of d is equals to 0, then we can say that x minus c and x minus d are the factors of f of x, means are the factors of the polynomial f of x. Okay, I hope my dear friends you understand these things. So my dear friends, these are the uses of factors theorem. Okay my dear friends, so now let's do some problems. So yes my dear friends, here question number 1 is determine which of the following polynomials has x plus 1 as a factor. Which of the polynomial has x plus 1 as a factor? So for this my dear friends, we have to check that if this polynomial is a factor of this x plus 1, means x plus 1 is the factor of this polynomial or not. Okay, so now my dear friends, with the help of factor theorem we can easily determine that. Okay, so now we have p of x is equals to x cube plus x square plus x plus 1. Okay, now my dear friends, 0 of x plus 1 is minus 1. Okay, if we put this value equals to 0, we get x is equals to minus 1. How? If we put x plus 1 is equals to 0, means x is equals to minus 1. X is equals to what? Minus 1. So now my dear friends, we have to put the value of x in this polynomial, like p of minus 1, which is equals to minus 1 cube plus minus 1 square plus minus 1 plus 1. Okay, here we get minus 1 plus 1 minus 1 plus 1. So this minus 1 and this plus 1 will be cancelled. This minus 1 and this plus 1 will be cancelled. So we get 0. So now my dear friend, here we get 0. So we can say that by factor theorem, x plus 1 is a factor of x cube plus x square plus x plus 1. Okay my dear friends, I hope you get this point. So now let's see in the next question, which is x raised to power 4 plus x cube plus x raised to power 2 plus x plus 1. Okay, so now this is what? This is equals to p of x. Okay, so now my dear friends, here we have x plus 1 is equals to 0. So we get x is equals to minus 1. So we have put the value of x in this equation. So now my dear friends, we get again p of minus 1 is equals to minus 1 raised to power 4 plus minus 1 raised to power 3 plus minus 1 square plus minus 1 plus 1. Okay, so we get 1, here we get minus 1, here we get plus 1, here we get minus 1, and this is plus 1. Now this plus 1 and this minus 1 will be cancelled. This plus 1 and this minus 1 will be cancelled. So we get 1. So now my dear friends, here is 1 is not equals to 0, means we can say that by factor theorem, okay, x plus 1 is not a factor. X plus 1 is not a factor of x raised to power 4 plus x raised to power 3 plus x square plus x plus 1. Okay, means x plus 1 is not a factor of this polynomial. Is not a factor of this polynomial. So my dear friends, I hope you understand these things. Okay, so my dear friends, if the zeros of x plus 1 is satisfied in the polynomial which will give 0, then we can say that x plus 1 is a factor of this polynomial. Otherwise we cannot say that this is the factor of the polynomial. Okay, I hope my dear friend you understand these things. So now again we have to put the value of, let's suppose this is what? This is p of x. Okay, now we have x is equals to minus 1. Okay, we have to put the value in this equation. So we get p of minus 1 here is minus 1 raised to power 4 plus 3 into minus 1 raised to power 3 plus 3 into minus 1 raised to power 2 plus, and here is minus 1 plus 1. Okay, so now if you solve this, we get 1, we get minus 3, we get plus 3, minus 1 plus 1. Again, my dear friends, we can cancel this. Here is minus 3 and plus 3 will be cancelled, minus 1 and plus 1 will be cancelled, and we get 1. We get what? 1. So my dear friends, again we can say that by factor theorem, x plus 1 is not a factor of p of x. Okay, so my dear friends, I hope you understand these things. Yes, so now we have, again this is p of x, so we have to find the value of p of minus 1. So we get, my dear friends, minus 1 cube minus of minus 1 square minus 2 plus root 2 minus 1 plus root 2. Okay, so we get, my dear friends, here is, this will become minus 1 and this is minus 1, and this minus will be plus. So here is, we get plus 2 plus root 2 plus root 2. Okay, and we get, here is minus 2 plus 2 plus 2 root 2. So this will be cancelled. We get twice of root 2. We get what? Twice of root 2. Okay, so this is not equals to 0. So again, my dear friends, we can say that here is, by factor theorem, x plus 1 is not a factor, of p of x, is not a factor of p of x. Okay, so I hope, my dear friend, you understand these things. So now, my dear friends, so the next question is, use the factor theorem to determine whether g of x is a factor of p of x, whether g of x is a factor of p of x in each of the following cases. Okay, so my dear friends, we have to use the factor theorem, okay, to determine whether g of x is a factor of p of x in each of the following cases. Okay, so my dear friends, for this we have a polynomial p of x is 2x cube plus x square minus 2x plus minus 1, and we have g of x is x plus 1. Okay, so for checking this, that g of x is a factor of p of x is okay, so for this we have to put this g of x is equals to 0. So my dear friends, here we get x plus 1 is equals to 0, so we get x is equals to minus 1. Now we have to place the value of this in this equation. So we get, my dear friends, we have to find p of minus 1. So if this is equals to 0, then we can say that g of x is a factor of p of x. Okay, so now here we get 2 into minus 1 cube plus minus 1 square minus 2 into minus 1 minus 1. We get, my dear friends, minus 2 plus 1 minus 2. Here is minus and minus, this will become plus, and we get minus 1. So now, my dear friend, this plus 2 and this minus 2 will be cancelled, and this plus 1 and this minus 1 will be cancelled. We get what? We get 0. So here is, my dear friends, we can say that, so by factor theorem, by factor theorem, we can say that g of x is not a factor, of p of x. Okay, my dear friends, I hope you understand these things. Okay, so now let's move on. Yes, here is, we have p of x is x cube plus 3x square plus 3x plus 1, and we have g of x is x plus 2. So now we have to see that, we have to check that g of x is a factor of p of x or not. Okay, so for checking this, we have to put the value of g of x is equals to 0. So we get x plus 2 is equals to 0. So my dear friends, here is minus 2. So this is the 0 of g of x, 0 of g of x. Now we have to put the value of this in this equation, put the value of x in this equation. So now Now we have to find the value of p of x at x is equals to minus 2. Here is we get minus 2 whole cube plus 3 into minus 2 square plus 3 into minus 2 plus 1. What is? Yes, my dear friends, plus 1. So now, my dear friends, we get minus 8 plus, here is 3 into 4. Here we get minus 6 plus 1. Okay. So minus 8 plus 12 minus 6 plus 1. Okay. So if we solve this, we get minus 14 plus 13. So we get minus 1. We get what? Minus 1. Okay. So my dear friends, this is not equals to 0. This is not equals to 0. So again, my dear friends, by factor theorem, by what? By factor theorem, g of x is not a factor of p of x. Okay. So my dear friends, I hope you understand these things. Yes. So now, my dear friends, we have p of x is equals to x cube minus 4x square plus x plus 6. Okay. And g of x is x minus 3. X minus 3. Okay. So now, my dear friends, for this, we have to place the value of g of x is equals to 0. So we get x minus 3 is equals to 0. So x is equals to 3. So this is the zeros of g of x. Zeros of what? G of x. Okay. I hope you get this point, my dear friend. So now we have to find p of 3. Okay. So here is 3 cube minus 4 into 3 square, 4 into 3 square plus 3 plus 6 plus 3 plus 6. So now 3 cube means 27 minus 4 into 3 square means 9 plus, here we get 9. So 27 minus 36 plus 9. Okay. So if we add 27 plus 9, we get 36 and we have minus 36. So my dear friends, this will become 0. Okay. So now here we can say that g of x is a factor of p of x by factor theorem. By factor theorem. Okay, my dear friends, I hope you understand these things. So my dear friends, these type of questions are very easy. So you have to just understand the concept of these questions, concept of this theorem. Okay. I hope, my dear friend, you understand these things. So now, my dear friends, so the next question is, find the value of k. Find the value of k if x minus 1 is a factor of p of x. If x minus 1 is a factor of p of x. Okay. In each of the following cases. In each of the following cases. So now, my dear friends, here in the question, it is already given that x minus 1 is a factor of p of x. Okay. So if this is a factor of p of x, so we can write, my dear friends, p of 1 is equals to 0. This is what? This is by factor theorem. Factor theorem. Okay. So my dear friends, by factor theorem, we can write p of 1 is equals to 0. P of 1 is equals to 0. Okay. So now here is, we are putting the value of x in this equation. So we get 1 square plus 1 plus k is equals to 0. So we get 2 plus k is equals to 0. So k is equals to minus 2, because if we shift this 2 in the RHS, so we get minus 2 because the sign will be changed. So my dear friends, this is our answer. This is what? This is our answer. Okay. I hope, my dear friends, you understand these things. So now in this case, again, we can write like p of 1 is equals to 0. This is what? This is by factor theorem. This is by factor theorem. Okay, because x minus 1 is a factor of p of x. So my dear friends, we get 2 into 1 square plus k into 1 plus root 2 is equals to 0. So we get 2 plus k plus root 2 is equals to 0. Okay, my dear friend. So now we are shifting the constant term to the RHS. So we get minus 2 minus root 2. Okay, now take the minus as a common. So we get 2 plus root 2. What is? Yes, 2 plus root 2. So this is our required answer. This is our what? This is our required answer. Okay, my dear friends, I hope you understand these things. Okay. Yes, so now let's move on to the next question, which is, my dear friends, here we have px is kx square minus root 2x plus 1. Okay, so now my dear friends, we have p of 1 is equals to 0 by factor theorem, because x minus 1 is what? It is a factor of this polynomial. So now my dear friends, here is k into 1 square minus root 2 into 1 plus 1, which is equals to 0. So we get k minus root 2 plus 1 is equals to 0. Now we are shifting all the constant term to the RHS. So we get k is equals to, here we get root 2 minus 1. K is equals to what? Root 2 minus 1. Okay. I hope, my dear friend, you understand these things. So now, my dear friend, this is enough for today, and we will meet in the next lecture with the next amazing topic. Okay. So thank you very much for listening me, and take care and goodbye.